Welcome. Today we'll verify the mean value theorem for the natural logarithm function on the interval from 1 to e. Let's start by stating our problem. We need to verify the mean value theorem for the function f of x equals natural log of x on the closed interval from 1 to e, and find the value of c in the open interval from 1 to e. Let's recall what the mean value theorem states. For a function that is continuous on a closed interval ab and differentiable on the open interval ab, there exists at least one c in the open interval where the derivative at c equals the average rate of change over the interval. Let's verify the conditions. First, we find that the derivative of natural log of x is 1 over x. Let's visualize this function. Here's the natural log function plotted from x equals 1 to x equals e. Notice that the function is continuous on this interval, and its derivative exists everywhere in the open interval from 1 to e. Now let's apply the mean value theorem formula. We plug in our values. F prime of c equals f of e minus f of 1. Divided by e minus 1. This gives us 1 over c equals natural log of e minus natural log of 1 divided by e minus 1. Since natural log of e equals 1 and natural log of 1 equals 0, this simplifies to 1 over c equals 1 over e minus 1. Solving for c, we get c equals e minus 1. Let's verify that this value of c is actually in our interval. Since e is between 2 and 3, e minus 1 is between 1 and 2. Therefore, c is indeed in the open interval from 1 to e. Let's visualize what this means geometrically. The slope of the tangent line at c equals e minus 1 is equal to the slope of the secant line between the points at x equals 1 and x equals e. Therefore, we have verified the mean value theorem for the natural logarithm function on the interval from 1 to e, and found that c equals e minus 1 is the value where the instantaneous rate of change equals the average rate of change.